Hi everybody, this is Chantel, and I am homesick and have sick kids too, so here I am teaching you from home. So today I'm going to talk about the multiple angle identities and the sum and product identities. I'm going to do things a little differently today because I couldn't get the technology to work to allow me to write on the screen while I'm going. So I'm going to go through this and just talk about the things you need to know, and then I'm going to have a separate video to show you examples and give you some problems to try on your own, just like we do in class. It's just going to be in a little different order. So this shows what we're going to be talking about. We're going to talk about the double angle identities, the power reducing identities, and the half angle identities, and talk about products and sums. So you need to have your yellow sheet with your laws and identities and one of your unit circles handy while we do this. So the first thing you need to know is the double angle identities. These are on your reference sheet in the top left-ish area. It says double angle identities. You might want to find that first, put a star on it or put a box around it or something, because you're definitely going to use this one a lot. And so I wanted to talk about what we mean by what is meant by a double angle. So if the angle is x, double the angle is 2x. If the angle is theta, double the angle is 2 theta. If the angle is 90, double the angle is 180. So these are important and can be derived using the sum identities. I'm not going to do that here, but it is in your book right at the very beginning of 6.3. But the double angle identities, if you use, if you look here at sine of 2x, if you use this as a sum identity, if you said sine of x plus x, and you treated each x as a and b and then combined like terms, you would end up with 2 sine x cosine x. Notice cosine 2x has 3 different ways to look at it because of the Pythagorean identity. You can rearrange this. All right, so the next thing we're going to look at is the power reducing identities. You need to add these to your sheet. So these are simply the cosine and tangent double angle identities rearranged. And so my question is, why do you think that these are considered power reducing? And since I'm not there, I'm going to answer it for you. If you look at sine squared x, you start with something squared and you end up with something to the with a degree of 1. So it reduces the power from the degree of the statement, the equation, from 2 to 1 in every case. So we're going from a degree of 2 down to a degree of 1. And here you need to pause, and everyone needs to add this to your blank yellow sheet that I gave everybody the other day. And if you don't have one, just grab a white sheet and have have it as your reference sheet for a continuation of the laws and identities for trigonometry. All right, so I'm going to move on. All right, these are the half angle identities. These are on your sheet and they are in the top right corner. So if you look here, all of these have been derived. If you want to look at the derivation, it is again in the book on page 525. So these are derived from the power reducing identities. If you take those and square root, you'll see the steps. It's, some of them are kind of long series of steps to get to this. So I did want to point out though that these tangent here are not on your sheet. The ones on your sheet look a little bit different. So wanted to pause the video at this point and add these to your sheet right where it says half angle identities, add them to the tangent choices. So now you'll have 3 choices for tangent. Okay, so the next one we're going to look at is identities relating products and sums, and this is written both ways on your sheet. And it says product to sum identities, and it says sum to product identities, so so that you can go both directions with it. This one is just written in the product to sum identities section, so that's about halfway down on the left side of the back side of your yellow sheet. So in some applications, we need a sum of trig functions, and in others, we need a product of trig functions. So we can use these to switch back and forth. So you can pause here and talk about these if you'd like. Okay, so the next identities that we're going to look at before I do some examples are the products relating products and sums going the other direction. So if you look at right in the middle of the back side of a yellow sheet, it says sum to product identities. And these are all there. And remember that our sheet says alpha and beta, and the book just uses A and B, and either one is fine. So I would pause here, take a look, make sure you can find it on your yellow sheet, and that you have made note of it, that these are going to be used. Okay, so I'm going to stop this video here, and knowing that you have your reference sheet right in front of you, I'm going to have a new video, and it's going to be just simply working examples. So I'll see you soon.